Welcome. In this video, we're going to be looking at solving one and two-step equations. So when solving an equation, the goal is to isolate the variable, and that means get it by itself. So in the end, we should have your variable, whatever that is, on one side of the equation all by itself. So it could be x equals something or something equals y. That variable is by itself on one side of the equation. The steps of solving, we are going to work backwards through the orders of operations. So if you use the mnemonic PEMDAS, we're really thinking SADMEP. Remember, you can look at our operations we're looking at the most to least powerful when we're doing our operations. When we're undoing them, we're undoing the least to most powerful. I like to think about the analogy of getting dressed. When you put on your socks, then you put on your shoes. If we're undoing those things, we have to undo it in the reverse order. We have to take off our shoes before we take off our socks. That also means we have to be doing the opposite, right? Putting on, taking off. And opposite in math, we're going to be looking at our inverse operations. So inverse operations, right? Addition and subtraction are inverse operations. Multiplication and division are inverse operations. Squaring and square roots are inverse operations. So we're doing the opposite operation as well as the opposite order to undo what we were doing on one side of the equation. So for any operation that you do to one side of the equation, you must do to the other. An equation is really like a balance. And so if the two things are equal, in order to maintain that equality, we have to use, they're called the properties of equality. So if we add something to one side of the equation, that's fine, as long as we also add the same thing to the other side of the equation. Same thing with all of our basic operations. So addition, subtraction, multiplication, division. As long as you do it to both sides, we will maintain that equality. So let's look at some one-step equations here and solving these one-step equations, thinking we're undoing the operations shown. So in these, we don't really have to think about which operation to do first because there's only one thing to be done. We just have to do the opposite. So here I have -7 plus x equals 5. And we think, oh, I'm adding, so I need to subtract. But if we take a look at the thing we're trying to get rid of here, this -7, to get rid of -7, we are going to add 7. Because we could rewrite this as x minus 7 if we wanted to. So utilizing that, if I add 7 to the left side of the equation, right here is my balance point. I need to also add 7 to the other side of the equation. -7 plus 7 goes away. That was the whole point there. We're left with x here equals, and then 5 plus 7, we get 12. Okay, same thing here. We're thinking, what operation are we doing? We're going to use its inverse operation to undo it. So if I have 3x, anytime we have anything just shoved next to each other without an operand in there, you could always write in that multiplication symbol. 3x really means 3 times x. So if we want to undo 3 times x, we're going to divide by 3. Divide by 3. 3 divided by 3 is 1. So we're just left with x. And -24 divided by 3 is -8. So we get x is -8. Okay, here we have something that looks like a fraction, x over 4, x fourths. Okay, keep in mind, fraction bar is division. So this is the same as x divided by 4, right? X fourths is x divided by 4. So to undo division, we're going to do its operation. We are going to multiply both sides of my equation by 4, maintaining that balance using that multiplication property of equality. So x divided by 4 times 4, our 4's divide out, and we're left with x. And -5 times 4 is -20. So we get x equals -20. Okay. Slightly different one. We have some multiplication, but it's a multiplication with a fraction. So -3/4 times x equals -9. So you might keep in mind that we don't divide fractions. So I could divide by -3/4. But if you remember what it looked like when we did that division by fractions, we end up multiplying by the reciprocal. So here, to undo a fraction, multiply by the reciprocal. So we're going to multiply both sides by -4/3 times -4/3, because here 4 divided by 4 divides out, 3 divided by 3 divides out, negative times negative is positive. We're left with x equals, here we can do some simplifying too. Remember, anytime you have a whole number, that whole number is over 1. So I can divide out anything in my denominator with anything in my numerator. So 9 and 3 both have a common factor of 3. 9 divided by 3 is 3. 3 divided by 3 is 1. Makes our multiplication a little easier. Also helps us get to our answer a little faster. So if I have -3 times -4, negative times negative is positive. 3 times 4 is 12. And 1 times 1, I could write 12 over 1, but that's equivalent to just 12. Okay, I want to pause here for a second because I want to address one of the nicest thing about solving equations is that you shouldn't even need an answer key to know if you have the correct answer. If you take this answer that you got here and plug it back in to the original function, you should be able to tell if it's correct. So if I take -7 plus 12, do I get 5? If you're not sure, you could use a calculator to check, but yes, -7 plus 12 is 5. Is 3 times -8 -24? Yes. -20 divided by 4, is that equal to -5? Yes, so I got the right answer. So in a little more work, 12 times -3/4. So we can multiply, then divide, or divide, then multiply, either way here. So 12 divided by 4 is 3. 3 times 3 is 9. But it's a -3, so we get -9, which is what our other side was equal to. So the nice thing about these equations is that we can find that answer, uh, know if it's correct, whether or not you have an answer key. Two-step equations. Okay, this is where we get to practice the backwards part of our order of operations. So just think whatever the last operation you would do, that should be the first operation that you undo. Okay, so if I knew what my value of x was here, I would multiply it by 6, then subtract that product from 10. Okay, so this 10 is the last thing I would do, so it needs to be the first thing I will undo. It's a positive 10, so we're just going to subtract 10 from both sides of our equation. So we use subtraction, that's our subtraction property of equality. Here, 10 minus 10 is 0. We're left with -6x. And here, -20 minus 10, we get -30. Okay, -6x equals -30. This again, if you're not sure, put in that little multiplication symbol. It's -6 times x. So to undo multiplication, its inverse is division. So we are dividing here. -6 divided by -6, it's 1, so we're left with just x equals -30 divided by -6 is 5. So we have x is 5 as our final answer. And again, we could take that and plug it back in here. Say 6 times 5 is 30. 10 minus 30, is that -20? Yes, it is. Okay, let's try another one here. We have two operations here. We're division and subtraction. Think if I knew the value of x here, how would I simplify this? I would divide, then subtract. So we are going to add, and then -3 plus 3 divides out, or has 0, so that goes away. 7 plus 3, we get 10. Now we have x divided by 4. Remember, anytime we have a fraction bar, that's just division. So we can multiply by 4, we get x equals 40. Okay, this last part down here, we already talked about a little bit with our subbing back in, but to determine if something is a solution to an equation, we are going to substitute the value in for the variable and see if the equation is true. Wow, true. So if we want to determine if x equals 4 is a solution to this equation, all we have to do is plug in 4 and see, does this work? 9 times 4 is 36. Is 11 minus 36 equal to 47? Okay, and when you get to this point, you can figure out what 11 minus 36 is. It's negative 25, or you could just say, ooh, it's not 47, so this is not a solution. All right, let's try another one. If I want to find x is negative 5. One thing I didn't note, but is really important, when you are substituting in a value for a variable, it is a very good idea to always put it in parentheses. So if I want to just look at this one, 55 equals 3, and then we're plugging in negative 5 for x and negative 5 for x. And those parentheses are important, especially when you're simplifying here, because this negative 5 squared, that means negative 5 times negative 5, which is positive 25. So we'll have 3 times 25 plus 4 times negative 5, negative 20. My 3 times 25 is 75, plus negative 20 is the same thing as minus 20. So is 75 minus 20 equivalent to 55? Yes, it is. So we get 55 equals 55. So yes, negative 5 is a solution to this equation. When we plug it in, it works for the value of our variable. Okay, that is all for our video today. Thank you for watching.